In densely populated places like New York City, public transportation is critical. There are many ways to get around in a city. Two of the most common are the subway or simply walking. When neither of those options are convenient, people often opt to hail a taxicab. Taxis have long been a profitable business due to their role in cities, although recently businesses like Uber or Lyft have begun dominating the market. It was just stated that these other services have skyrocketed in popularity. So, why is taxi data even relevant? It's because the difference between them really lies in how they are requested. The ability to request a ride to a destination completely through a phone application is something that many people find more convenient than, say, hailing a cab from the street. The fundamentals of the businesses are still the same as taxis. A user requests a ride from point A to point B. The price is calculated based on distance and time. Tips are given based on the customer. All other little pieces, such as ratings or GPS tracking, are merely features to improve the user experience. Until there is a significant shift in the nature of the service, data collected from taxis is applicable to businesses in the same area running the same model. There are several goals for this project. The first is to analyze several regression models to determine what works well with the basic dataset. This model will be used to predict tips given by customers to taxi drivers. The second is to determine if training on additional factors improves the accuracy of the model, and the third is to identify if additional factors correlate with higher or lower tip rates. So, why is this type of information important? Many modern ride services allow people to create their own hours. Since a significant portion of income is earned by how much a customer tips, predicting how much a driver will receive and what factors influence it could help people to decide the best times to work. Given the datasets, the right side shows the attributes that will be significant for this project. I will have a base model comprised of taxi attributes and then add on additional ones from the list, such as snowfall. Since I am doing regression, I have to measure the error of the model. Root mean squared error was chosen for its reputation as a general error metric. The model RMSC will be evaluated through cross-validation. I started by training the data on the month of January from the taxi dataset where the tips have been calculated. This model, once relatively accurate, will serve as the base model and will be applied to all months in the year to receive unseen tip predictions. This project is still in progress, but so far I found after testing several regression models, including polynomial regressor and standard decision trees, that the random forest regressor performs with the least amount of error. The next steps will be to incorporate the additional factors into the training of the base model and see if they make the regressor more or less accurate. As the final step, when all predictions have been made for the year of 2015 from all of the altered models, I will graph the relationships between specific attributes and the amount given in tips. This will hopefully help taxi drivers decide when to work.